This video is about another important Kubernetes object, stateful sets. They are quite valuable and have various use cases in real-life application deployments. It is a vast topic to understand and has quite a few characteristics. We will do an introduction to stateful sets here, and we will revisit it after we have understood the storage in Kubernetes. Stateful set is the workload API object used to manage stateful applications. They are intended to be used with stateful applications and distributed systems. Like a deployment, a stateful set manages pods that are based on an identical container spec. But unlike a deployment, a stateful set maintains a sticky identity for each of their pods. It provides guarantees about the ordering and uniqueness of these pods. These pods are created from the same spec but are not interchangeable. Each has a persistent identifier that it maintains across any rescheduling. If an application requires any stable identifiers or ordered deployment, then stateful sets are a good candidate to use. Otherwise, we can deploy application using a workload object that provides a set of stateless replicas, example deployment or replica set. Stateful sets currently have a few limitations. They require a headless service to be responsible for the network identity of the pods. We need to create this service. And stateful sets do not provide any guarantees on the termination of pods when a stateful set is deleted. To achieve ordered and graceful termination of the pods in the stateful set, we should scale the stateful set down to 0 prior to deletion. For a stateful set with n number of replicas, when pods are being deployed, they are created sequentially in order from 0 to n-1. And similarly, when pods are being deleted, they are terminated in the reverse order from n-1 to 0. Let's understand it through an example. Firstly, we will create a headless service, which will be used to control the network domain. And then we have the specifications for the stateful set. The name of the stateful set is nginx-ss. It will be created in the Whizspace namespace. The spec indicates that there will be 3 replicas of the nginx container, which will be launched in unique pods. When the nginx example above is created, 3 pods will be deployed in the order of nginx-ss-0 to number 1 and then the number 2. The number 1 pod will not be deployed before number 0 is running and ready, and number 2 will not be deployed until the number 1 is running and ready. The domain managed by this service takes the form of servicename.namespace.svc.the cluster domain. As each pod is created, it gets a matching DNS subdomain where the pod name is appended to the service domain. The governing service is defined by the service name field in the stateful set spec. Rest all of the fields are the same as deployments, which we have already covered. Before creating the stateful set, I will put the pods on watch so that we can observe the order in which they are created. Let's apply the YAML for the stateful set, and we'll keep a watch at the pods as they get created. So number 0 is getting created first. When it gets in ready state, number 1 gets started. And once the number 1 gets in running state, then the number 2 gets started. So you can see all the 3 pods are in running state. We also have a headless service created. And we can see that it is associated to all the 3 pods. In order to understand it further, I will create a standalone curl pod. This will create a standalone curl pod and keep it running. Let's verify the FQDN that is provided to each of these stateful set pod. And we can see the FQDN is the name of the pod, followed by the service name, the namespace, SVC, and then the cluster domain. Similarly, for the other stateful set pods, the only difference is in the pod name. Any pod running in the cluster should be able to reach a specific pod using the FQDN. So from the curl pod, we should be able to ping to any of these pods. And we can see it is pingable. Similarly, we should be able to access these services which are running inside these stateful set pods. The service is running on port 80, so if I curl, we should see the Nginx homepage, which we can see successfully. If any of these stateful set pods crashes and has to be recreated, then it should get created with the same name in order to maintain the sanity of the application. Let's check that as well. I will delete an existing pod. And here we can see that the pod gets recreated with the same name. We can verify from the age of the pod that it just got created.
For more details, check the link in the description. Learn with Whizlabs. Success certified.